Heating and cooling is set to take center stage in the next decade of Europe's energy transition, but this cannot happen without decarbonizing the sector. Aurélie, what are the biggest challenges in decarbonizing the sector?
Well, actually, the biggest challenge, I would say, and start with, is the size of the sector. We're looking at half of our energy demand, with more than 60% coming from fossil fuels. So in this case, size does matter. In particular, because you have a lot of other sectors that are trying to decarbonize at the same time, and that are competing with renewable electricity sources to decarbonize their processes. So we have a huge demand, but we also have a demand that is not like any other demand. It is very seasonal, so peaking in winter and in summer. And here you're looking at huge peaks that are dimensioning the system. So it is seasonal and variable, also intraday and in between the weeks or the months, because it's weather dependent. So you need sources that you can activate at any point in time that are available and dispatchable. And that's one thing we miss. We know that the base load, the flexibility of the system is still lacking. And so one of the consequences that we have is a stronger volatility in our system. And with regards to heating and cooling, the peaking demands translate into peaking prices for consumers and for industries. So affordability, in our case, is extremely important.
Okay, so why do you think it's so important to look at decarbonizing heating and cooling from a whole systems perspective?
Because indeed, as I said before, sometimes we tend to simplify the challenges that we face and think that it's enough to develop renewable electricity sources, where we have done amazing progress. It's important, but you need to look at the needs of the system in terms of being able to provide this energy at all time, clean energy at all time and at an affordable price. And for that, you need to play on the complementarity of the energy sources and the complementarity of the energy infrastructures. And in particular, the district heating and cooling sector, which is the one that I represent. It's different infrastructure. It's heat infrastructures, water pipes, that are not often very much mentioned, but actually procure immense services in terms of storage, seasonal storage, playing with the flexibility and the grid with large heat pump units, for example, and most importantly, complementing the contribution of renewable electricity sources to decarbonize by bringing in new clean sources like geothermal energy or solar thermal energy, and also waste heat sources. So that's heat that is produced today from cooling processes or industrial processes, and that is going to waste, basically, and that we can actually retrieve to then supply buildings. And I just want to say that this is not anecdotal. This is far from being anecdotic, because the total potential of those sources that we can bring to the system is estimated to 2,000 terawatt-hour per year. And it is more than the total European heat demand forecasted in 2050.
Okay, so now looking forward, what are the technology trends making waves in this space, and is there enough support to get this technology deployed?
So in terms of the key technological enablers, we are looking into, for example, technologies that will help us harvest those sources I was mentioning before. So here, for example, large heat pump units are extremely interesting. They are very efficient, and they can help us make the most of waste heat, or even shallow geothermal, which is a geothermal a bit less hot than the one we're trying to retrieve deep down. So that's an important trend at the moment. Of course, cogeneration is taking a stronger role to stabilize the system, and we have seen the important contribution of this technology in the turmoils that we faced in the early days of the energy crisis. And in general, our energy infrastructure is evolving very fast. So low temperature district heating, as we call it, it's a smarter, more efficient heating and cooling networks with much reduced losses. So they provide a much bigger efficiency and also the ability to integrate a much broader variety of clean and renewable heat sources.
Wow, Aurélie, thank you so much for sharing your insights. To hear more insights, join the Enlit community.